Hello everyone. Hello everyone. So till now we have discussed all the concepts of a Fourier series. So now before starting the problems, let's discuss some formulas that would be applied in the upcoming problems. These formulas are in the case when in the problem when we give the value of f of x as e power anything of x, like e power 1x, e power 2x, e power ax in generally. Okay, so there are a few set of formulas for that, and also we will discuss the formulas for some trigonometric functions also. So we have written here 3 4. So we'll start now. So the first formula is e power ax sine bx plus c, where a, b and c are constants. There will be some numbers in that place. So these are the formulas for that. See, in case if we get the integration of e power ax sine bx plus c or cos bx plus c, we have this set of formulas. For sine bx plus c, we have e power ax divided by a square plus b square into a sine bx plus c minus b cos bx plus c. And for e power ax cos bx plus c integration, we have e power ax divided by a square plus b square, a cos bx plus c plus b sin bx plus c. So this is basically we need to avoid the Bernoulli's rule here, because we know that for integration of e power x is e power x itself only, right? So the integration will not stop at one point, it will go on be going, while as the differentiation also will be go on going. So to avoid that thing, we have one formula for this. So that's why we are going to apply this thing. Now in other case, we have the formula for sine 2n pi is equal to 0. We know that sine n pi is equal to 0, right? We have used in many problems the formula for sine n pi is 0. So how it is 0? The value of n is from 1 to infinity. So let's think that value of n is 1. So if the value of n is 1, then it becomes sine pi. We know that sine pi is 0. If sine 0 is 0, then sine pi, sine 2 pi up to sine n pi, all the terms are 0. So in the same case, we can even say that sine 2n pi is also 0. Okay. So now we have the formula for cos n pi. So I have not told you about this, but we have applied this formula in many problems. We have applied this formula for many problems in before. So I am going to tell you now how it is. Cos n pi is equal to minus 1 to the power n. How this has come? So we know the value of cos 0, right? That's 1. And we also know the value of cos pi, that is minus 1. So substitute if cos pi, then cos n, the value of n becomes 1, right? Cos 1 pi is equal to cos pi, that's equal to 1. So if we substitute the value of n here as 1, it becomes minus 1 to the power 1, that is minus 1. So we got the value of cos pi, that is cos 1 pi is equal to minus 1 to the power 1, that is equal to minus 1. So similarly for cos 2 pi, the value of cos 2 pi is plus 1. We know, right? For cos pi it is minus 1, cos 3 pi by 2 it is 0, cos 2 pi is plus 1, and it goes on like that. Minus 1, 0, plus 1, 0, minus 1, it goes on like that. So in order to avoid that, we have this general formula, minus 1 to the power n. So in case of cos 2 pi, to get the answer as plus 1, substitute the value of n as 2. It becomes minus 1 square. We know that minus 1 the whole square is plus 1. Minus 1 into minus 1 is plus 1. So this is the general formula to find cos n pi. Similarly, we have the formula for cos 2n pi, that is minus 1 to the power 2n. This 2n will be the power, you have to write that. So minus 1 to the power 2n is always 1. How it is 1? See, the value of n here also it tends from 1 to infinity. You put any value for n. For example, let's take the value of 1. 2 into 1 becomes 2, right? The power is multiplied with 2 always for any number. So 2 into 2, it also becomes 4. So whatever the answer we get, right, all of them are even. So we know that minus 1 to the power any even number will give you 1 itself as the answer. So we can say that the formula for cos 2n pi is plus 1. So these two formulas, right, cos 2n pi and sin 2n pi, we are going to use these formulas in the intervals from 0 to 2 pi mostly. Okay, so now we'll get ahead with some problems. Yeah, so this is the first problem. Find the Fourier expansion if f of x equal to 2 pi x minus x square in the interval 0 to 2 pi. So the given function is 2 pi x minus x square. We know that in case of 0 to 2 pi, we need to substitute the value of x as 2 pi minus x. So now we'll substitute the values. Whole square. So this becomes 4 pi square minus 2 pi x minus 2 pi whole square, that is we need to use the formula for a minus b whole square. A square, that is 4 pi square plus x square minus 4 pi x. That becomes 4 pi square minus 2 pi x minus 4 pi square, you have to remove this bracket, minus x square plus 4 pi x. So here we can see 4 pi square gets cancelled. So 4 pi x minus 2 pi x will give you 2 pi x minus x square. So here we can see that f of x and the answer we are getting is matching. So this is equal to f of x. So we know that if f of 2 pi minus x is equal to f of x, then the function is even. So in case of even function, we know that bn equal to 0. So now we will find the value of a0 and an. For the formula for a0 is 2 pi 0 to pi f of x cos nx dx. So now we'll substitute the value of f of x 2 by pi 0 to pi 2 pi x minus x square cos nx dx. So now apply the Bernoulli's rule. The integration of cos is sin nx by n, minus you have to differentiate this function. The differentiation of x is 2 pi and the differentiation of x square is 2x. 2 pi minus 2x, and again we have to integrate this, that this becomes minus cos nx by n square minus cos nx by n square plus, so the differentiation of 2 pi is 0 and 2x is minus 2 into minus sin nx by n cube. Apply the limits. So now we'll substitute the limits. 2 by pi into 2 pi into the limit is 2 pi minus 2 pi whole square into sin 2n pi by n minus 2 pi minus 2 into 2 pi minus cos 2n pi by n square plus 2 sin 2n pi by n cube minus the lower limit. that is this becomes 0 sine 0 by n minus 2 pi minus 0 minus cos 0 by n square plus 2 sine 0 by n cube. So now we will further solve this. So here we can cancel out some terms. The value of sine 2n pi, we have seen that the value of sine 2n pi is 0. I have told you before. So this whole term becomes 0, and even this term becomes 0. This term becomes 0. Sine 0 is 0. Even this term becomes 0. So now we will write the remaining terms. That is minus 2 into 2 pi is 4 pi. Minus cos 2n pi by n square. And here we can see that 2 pi minus 0 is 2 pi. It becomes minus 2 pi. Minus into minus is plus. So it becomes, and cos 0 is 1. It becomes plus 2 pi, and there is a minus sign outside. So we can write it minus 2 pi by n square. Yeah, so now we will further solve this. 2 pi minus 4 pi is minus 2 pi. So we have minus here, we will write it minus plus 2 pi. There is minus here, so we will write cos 2n pi by n square minus 2 pi by n square. So here we can take minus 2 pi by n square outside. So it becomes minus 4 pi by pi n square into the value of cos 2n pi is 1. We have seen it. And plus 1. Minus 8 by n square. So this is the value of a naught. Yeah, so I want you all to make a small correction. So I made a mistake while writing a formula. In case of I wrote a naught and I wrote the formula for an. So just don't need to worry, just change this a naught by an, and now we'll find the value of a naught. Till now we were finding the value of an. So just please correct this mistake if you have noted down. Sorry for this. So now we'll find the value of a naught. F of x is 2 pi x minus x square dx. Integrate this becomes 2 pi x square by 2 minus x cube by 3, 0 to pi. Here 2 gets cancelled, therefore a naught equal to 2 by pi into pi x square minus x cube by 3, 0 to pi. A naught equal to 2 by pi into pi square. It becomes pi cube minus pi cube by 3. So here the minus the limit of 0, this whole term becomes 0. So I am not going to write that. So let's write it minus 0. 3 pi cube, you have to cross multiply this. 3 pi cube minus pi cube by 3, that will give you 2 pi cube by 3. So we can cancel one pi term. So a naught equal to 4 pi square by 3. So now we have found the value of a naught as well as an. So now we will write the Fourier series. So this is the required Fourier series. So the value of a naught is 4 pi square by 3. So a naught by 2, so it becomes 4 pi square by 6. 4 and 6 we can cancel it and make it 2 and 3, so it becomes 2 pi square by 3. Summation from n tends to 1 to infinity, the value of an cos nx. So this is the Fourier series. So now we'll try and try one question related to a discontinuous function. So we'll get to the question in a while. So yeah, this is the second question. Obtain the Fourier expansion if f of x equal to 2 pi minus x in the interval 0 to pi and minus x in the interval pi to 2 pi. So now let's solve. There are two functions. Discontinuous function phi of x is equal to 2 pi minus x. So first step is phi of 2 pi minus x, that is 2 pi minus x, that is equal to 2 pi multiply minus 2 pi plus x. So this gets cancelled, so the final value of 2 pi minus x is plus x. So here we see that phi of 2 pi minus x is equal to minus xi of x. How it is minus xi of x? Most of you will ask it now. Because the value of xi of x is minus x, right? So if we substitute it as minus xi of x, it becomes minus of minus x, it becomes plus x. So the same thing, we got the answer it as plus x. So we can say that it is an odd function. So in case of odd function, we know that a0 and an both are equal to 0. So now the only thing left is that we need to find the value of bn. So we'll find it. So we'll find the value of bn. Substitute the value of f of x from 0 to pi, that is 2 pi minus x sin nx dx. Apply the Bernoulli's rule. The integration of sin is minus cos minus 1. The integration of the differentiation of 0 is 0, 2 pi is 0 and x is 1, minus sin nx by n square, limits from 0 to pi, 2 by pi into, substitute the upper limit, 2 pi minus pi minus cos n pi by n minus, so it becomes minus into minus, plus into minus, minus, so minus sin n pi by n square, minus the lower limit, that is 2 pi minus 0 is 2 pi, I'll write this minus outside, cos 0 by n, again minus sin 0 by n square. So it becomes 2 by pi, 2 pi minus pi is pi, so I write it this pi out, minus sign outside, cos n pi by n minus sin n pi by n square, minus into minus is plus, and the value of cos 0 is 1, so plus 2 pi by n. So this becomes 0, so I'm not going to write that. So here this term gets cancelled, sin n pi is 0. We'll continue. So the value of bn becomes, we have to take pi by n outside, that is 2 pi by n pi, it becomes 2 minus cos n pi. This pi gets cancelled, bn equal to 2 by n into 2 minus 1 to the power n. The value of cos n pi is minus 1 to the power n. Bn equal to 2 by n into 2 plus the identity we need to use, that is minus 1 to the power n plus 1. So this is the required bn value. So now we'll write the Fourier series. So the only term left is bn, so bn n plus 1 sin nx. So yeah, this is the required Fourier series for this one. Yeah, so in this session we have discussed the integrals related to e power x and 2 sums related to the interval 0 to 2 pi, and we will solve some more problems in the next sessions. Thank you. So if you have any doubt, please comment down if you have any doubt. And if you want some notes related to this Fourier series, please go into the description. There will be a website related to this notes, and you will be getting all the notes of this Fourier series. If in case if I did some mistake while doing this session, if you can refer those notes. All the solved problems in the session, I've written it down in that notes, so you can copy those. Thank you one and all. Let's see you in the next session.